Hey guys, today we're going to do another implicit differentiation video. This problem is a little bit trickier, so if you want some simpler problems, please first refer back to the video previously in this playlist. So just to recap what we mean by implicit differentiation, what we want to do is just take the derivative with respect to x of the entire problem statement. And that's just a fancy way of saying every time there's a y value, so we're taking the derivative with respect to x of a y, we just want to write the derivative and make sure we add this dy dx term because the resulting solution of these types of problems is dy dx equals something. So first we start by taking the derivative of each of these terms. We'll notice that the first term is actually a composite function, so we're going to do the chain rule over on the side here later in a second. The derivative of y squared is 2y, but this is implicit differentiation, so we got to remember to add the dy dx term here. And then the derivative of 1 is just 0. So let's apply the chain rule to get the derivative with respect to x of cosine of x of y. This is a composite function because we are multiplying two terms within the cosine itself. Please look at this video for a more in-depth chain rule explanation if you need, but I'm going to assume we remember how to do the chain rule for the most part here. So we have u defined as the inside of the function, xy, and f of u is the outside of the function, which is cosine of u, because we replace the inside with the term u here when we're doing the chain rule. So now we have to take the derivative of these two terms, du and f of u. So du dx of xy is actually going to be a product rule application. The derivative of f of u, f prime of u, is going to be negative sine of u. And before we go ahead and finish the chain rule, which is going to be this value multiplied by this value, let's move down here in yellow and just apply the product rule real quick to get the derivative with respect to x of xy. If you want a more in-depth view of the product rule, please look at this video previously in the playlist, but we're just going to jump right in with a simpler explanation. This one. So u equals x, the first term, v equals y, the second term. Deriving both of these terms, du dx is going to be 1. dv dx is also going to be 1, but we need to make sure to add the dy dx term because we're taking the derivative of a y with respect to x. To complete the product rule, the final derivative here is v times du dx, which is y, plus u times dv dx, which is x times dy dx here. So we need to plug in this function into our chain rule work up here. And now we can finish out our chain rule derivative, which is going to be du dx times f prime of u. In other words, we have y plus x times dy dx, all multiplied by negative sine of u, which in this problem is xy. Now we have to take our answer to this derivative and plug it back into our initial problem. So to make a long story short, the derivative of cosine xy is actually y plus x times dy dx, all times negative sine xy. Then we add the 2y dy dx equals 0. So this is what I call step 1 of implicit differentiation problems. Step 2 is isolating the dy dx so that we can get our final answer in the form of dy dx equals blank. If you made it this far without making any simple mistakes, you're definitely on your way because it's just some simple algebra to deal with now. So first, let's distribute this negative sine xy multiplied by each of these terms that we're adding here. So negative sine xy times y plus negative sine xy times x dy dx plus 2y dy dx equals 0. So now we move over the only term that doesn't have the dy dx value in it so that we can isolate the dy dx and come up with our final answer of dy dx equals something. So we're going to have negative sine xy times x dy dx plus 2y dy dx equals negative sine xy times y. And then we can isolate out the dy dx. And inside the parentheses, we'll have negative sine xy times x plus 2y equals negative sine xy times y. I know it's a lot, so let's hope we kept track of all our work correctly. And finally, we can come up with our answer of dy dx equals negative sine of xy times y all over negative sine of xy times x plus 2y. I know that was a lot and there's a lot of terms in this problem, but I promise you this is the type of problem that will definitely set you apart and help you beat out the curve and pass that calc class. So I'll leave you with just a good luck, everybody. Good luck on your exam. I hope this was helpful. Please comment down below any other types of problems you'd like to see, and I'll see you in the next one.